So today I'm going to give you a little Lightning Protection 101. I'm a certified presenter for the Lightning Safety Alliance. Normally I give this presentation to architects, engineers, just to give them a understanding of lightning protection, how to plan for it, what to think about it. You guys in the industry you're in are a little more understanding of grounding and stuff like that, so this should be fun. I will have some question and answer at the end, but if there's something that pops up during it, feel free to interrupt and ask a question. I have no problem keeping this very interactive. So we'll just start here. I always have to read the first one for my credentials, but the Lightning Safety Alliance is a registered provider with the American Institute of Architects Continuing Education Systems. There is credit earned for completion of this program for CES credits. The Lightning Safety Corporation, we're not-profit. It's a leader in education for lightning protection. So what we're going to talk about today is we're going to talk about kind of the general understanding of lightning protection systems. We're going to talk about the 5 essential elements of the lightning protection system. We're going to identify areas people should consider when specifying lightning protection systems. So a couple interesting lightning facts and figures I wanted to touch on. We'll go through what is lightning, the elements of the system, the standards and requirements that we follow as certified lightning protection professionals, different quality assurances, and beware of the up and coming and been around coming from overseas non-conventional methods of lightning protection. Some facts about lightning. Well, a bolt of lightning can generate 50,000 degrees Fahrenheit in heat. That is 5 times hotter than the surface of the sun. So it can be extremely hot and obviously extremely dangerous and deadly. Lightning travels at 90,000 miles per second. Very high intensity, very short duration. Thunder travels 0.2 of a mile per second. So the old saying of 5 seconds between the flash and the bang means the lightning is 1 mile away. That is absolutely true. This is the Visala map. This is updated about every 5 years. And so what it does is it tracks the density of lightning strikes in the US. As you can see, kind of the farther southeast you go is where the lightning is more frequent, more dangerous. Actually, Florida and Alabama flip-flop about every year and Mississippi now, for most lightning strikes. You get up into our neck of the woods, you see we're in that yellow-orange range. They just kind of updated the map this year, and it's not published yet, but that orange will extend a little more into Nebraska. You're seeing the trends where lightning is starting to be more of a frequent event across the country. As you can see on the West Coast, lightning is not dealt with very often, very few strikes, very few flash density. Some of the safety and economic consequences. 3 to 5% of all commercial insurance claims are lightning related. You see a lot of not only structural damage, but electrical damage, HVAC units, computers, things of that nature when a lightning strike occurs. $1 billion is the annual losses due to lightning in the US alone. The FAA estimates that lightning costs airlines $2 billion annually in operating costs and passenger delays. Every church has a big steeple on it. It's usually in most small towns the biggest thing there. So leading cause of church fires. You see a lot of that, especially in the smaller communities where the church is on a hilltop and then has another 80-foot spire heading up into the air. Lightning is one of the leading causes of weather-related deaths. So this year we're actually down year to date in the country, which is very exciting. But you have a lot of deaths, especially down in the Gulf area, just from people not paying attention to the thunder roars go indoors and they get struck by lightning. 250,000 insurance claims for lightning damage are paid every year. The average claim is $7,400. Seems like a fairly small number, but out of the 250,000 claims, that number adds up pretty quick. These are just some different photographs that we've had of occurrences where lightning has struck a structure and obviously caused a lot of damage. Commercial buildings, residential, it doesn't matter. Lightning, when it hits an object, it's trying to get to ground and get to earth, and there's not a lot of good construction material that allow that to happen. These are kind of some photos of after the fact. And these are some homes in Texas that got hit. These are some pictures here of some big towers, chimneys, stone chimneys. Lightning protection originally was invented, obviously, to protect the structural integrity of the building. So when lightning hits things like stone and brick and masonry, it causes a lot of damage. I'm going to show you guys a little video that we caught here. Kind of goes through. You can see how that lightning strike just hit, nailed that tree, and cut it right in half. There's another one that we don't have access to through the LSA, which is interesting, but there's some camera footage of a gas station in Mobile, Alabama, where lightning hit across the street, just hit the ground, traveled underground through metallic piping, and about 4.5 seconds later, the gas station virtually exploded. So what is lightning? One of the things when I do this presentation to school kids too across the Midwest, and one of the best ways I explain it to them is if they've ever walked across the carpet in their socks and then they touch a door handle and they get that shock. That's virtually the same thing as lightning. Lightning, by definition, is the discharge of atmospheric electricity from one cloud to another or from cloud to earth. It's a phenomenon that has a massive spark of discharge electricity. And you'll see later in the presentation, I have some neat different videos and photographs of some different types of strikes. Again, we kind of talked about that when you walk through the room in your house and you build up that friction and you get that shock. That's very similar as when you get the particles in the clouds rubbing together, creating that and getting that atmospheric discharge. That's what happens in a thunderstorm. So we're kind of going through the different charges of the ions in the air and how these lightning strikes occur in the clouds. Also, there's a lot of different I shouldn't say rumors, but a lot of people think that there's only a couple types of lightning. There's actually quite a few. Obviously, cloud to ground is one that you see a lot. Intercloud, so cloud to cloud, so you get a lot of ion charge up in one and it jumps to the other. You get the intercloud, you see those rolling in first normally, where you get the lightning that are just kind of flashing around in the clouds. Then you have the cloud to air, which is kind of the least frequent one you see, where it just shoots right up into the air. This is a capture of a lightning strike down in Kennedy Space Center. Down at Kennedy Space Center, they have to do a lot of things when it comes, especially in Florida, because the aircraft have to have very extreme variables on when they can take off and not. So a company called Scientific Lightning Solutions has built very intricate lightning detection systems and monitoring so they can study how the lightning strikes affect the area and what they can do to better protect these aircraft from being able to take off. And so they have these cameras all around the Space Center so they can study every strike as it happens and monitor them and map them. So you saw the first one strike there. There's another one they have here captured.
So let me ask a question, Rusty. Are the towers that we see now around the launch pads, they're specifically for for lightning discharges or to keep it from hitting the launch pad itself?
Absolutely correct. So with the up and coming of companies such as SpaceX and the private space programs, we actually helped design the new launch pad that's going up out there. So virtually all the towers and everything you see around that are absolutely designed for that. And between that and then the catenary systems around, we have to be able to, when the rockets are sitting on the launch pads, protect them from any potential strike as well. Very good question. So this is some of the data that they take from that strike we just saw. And then they turn everything in, and then they can document all these and really get a good feel of how the lightning is reacting around the area. And then when they implement, for example, a new launch pad, they can test how good it's actually protecting the launch pad itself. Here's one that they 3D mapped over Washington, D.C. that NOAA and NASA did. They also track the lightning of anywhere the rockets, or back when the space shuttles were around, were going to be coming back into the atmosphere. This is just kind of a simple model. Take a house, for example, and you get the ion buildups around certain particles or certain areas of a structure, and then that's where the lightning decides to strike, where it strikes. So next, we're going to kind of touch on the elements of an actual lightning protection system. Obviously, we have air terminals, we have our conductors, we have different bonding connections. In your guys' world, the most important things would be the bonding connections, the grounding terminations, and obviously the SPDs, the surge protection. The lightning protection industry follows 3 standards. Don't ask me why there's 3. They all read about the same, but they're all a little bit different. So the ANSI standard, the one that has the most intricate for specialty structures and installations, would be NFPA 780, UL 96A, and LPI 175. Again, all of them coincide with each other. 80% of them say the same thing, but each one has nuances for different structures, and NFPA 780 gets very in-depth for a lot of specialty things, flammable things, military ordnance, stuff of that nature. So in talking about a lightning protection system, we'll just use a building for an example. If you guys are ever driving down Dodge Street and you start about Methodist Women's Hospital and you start heading east, when people think of lightning protection and they're not familiar with it, they think of barns and old farmhouses where you used to have very tall air terminals with balls on them and stuff of that nature. Nowadays, lightning protection is quite a bit hard to see by the eye. So anyway, if you're driving down Dodge Street and you look, Methodist Women's in about every building, especially when you get down by Boys Town, the First National Bank area, Valmont, all those buildings down there. If you look up, you'll see the little spires about every 20 feet running around the outside of the building. So as you can see on this typical commercial building, we have our series of conductors and air terminals. Our air terminal placement are based on those 3 standards I mentioned before. A lot of times now buildings are built with structural steel. So instead of using physical downlead conductors to get our system up top connected to ground, we can use building steel, and we bond the building steel at top and bottom to make that dissipate the lightning down to earth. And then obviously we ground everything down below. One of the most important pieces of a lightning protection system is equal potential bonding. So all of the incoming services, metallic piping, whether it be water, gas, fire sprinkler, and electrical, tying all those services together and having them have equal potential with our system is very important. What we are trying to accomplish with that is side flash potential. The main thing that causes damage in a lightning strike is when it side flashes. All lightning is trying to do is get to ground. And when you provide a good grounded system and you tie in everything else, metal bodies, bonds, services, you're providing equal potential for everything, so it's going to take our system to ground. Again, same thing, but on a residential system. Residential typically is not a big thing anymore. Usually what you'll see is, you know, especially I think it was 2 summers ago, we had quite a few events in Omaha where houses got struck and actually had damage. So we usually do the person that got hit by lightning and their 3 neighbors about every couple years. And then you get a lot of new construction homes. If people had difficulty with lightning in the past, we'll retrofit their homes and run everything concealed for them. One of the things that's causing a lot of damage, and we'll touch on this later in the residential world, is CSST piping. It's the worst, terrible thing designed gas pipe that they ever could have invented. And what happens is if lightning hits a structure and it side flashes to the CSST piping, normally it will perforate that piping. Now you're causing a big torch to happen, and that's where you see a lot of the house explosions and fires. Normally it's caused if it has that CSST piping in it. Air terminals come in all shapes and sizes. Copper used to be the absolute norm in lightning protection for rooftops. However, with the advent in the mid-90s of UL and all the bodies figuring out that there's galvanic corrosion issues, and now everyone uses galvalume and cheaper metals on rooftops, units, stuff like that. Predominantly what you see is aluminum conductor and air terminals on commercial structures anymore because of the dissimilar metals concerned. One of the most important things in lightning with our standards is our rolling sphere method. This will give you kind of an idea of what happens. So you take a 150-foot radial ball, you can roll it over a structure, and everywhere that ball hits is where an air terminal will be placed. It's also done off our calculations. For an example, the perimeter of a structure will have an air terminal every 20 feet. So if you kind of watch this animation, everywhere this ball is rolling, there'll be an air terminal. As you can see on the lower roofs, you only see them on the outside edge because it's the higher roof to the lower roof is promoting a zone of protection, as we call it. Again, this was done by our partners at Scientific Lightning Solutions. They do a lot of these great animations for us to be able to explain kind of how our science and methodologies work. So you can see now that the structure has air terminals on it and it's rolling over. So it's showing that it's not touching the structure anywhere. Some of the rooftop considerations that we do, I kind of touched on this, but we have to have 20-foot minimum on the perimeter of the building. Air terminals have to be within 2 feet of roof edges, corners, ridge ends. When you see a large structure that has a lot of flat roof, we have to have air terminals every 50 foot in the mid-roof. So basically every 50 foot, we make a grid and tie air terminals together. Rooftop equipment is probably the most susceptible. It's normally what sticks up through the roof, taller. So anytime you see a lightning protection system done correctly, you will see all the mushroom vents, HVAC units, antennas, stuff of that nature protected on the roof. More is more. I get a lot of my installation techs that try to get fancy with math and try to prove why they don't have to protect a certain piece on the roof, and that very well be the case. But our industry, we always say if it's in a threshold or close, just protect it. Then we know it's done, then we don't have to worry about it. Some different installation examples on the roofs. There's some side mounted on the parapet there. As you'll see, these are all aluminum where they're touching metal. There's a ridge mounted one there. Those are concealed, so they're running the conductor in the attic. And we use a threaded rod connector to get through the roof, seal it on both ends so it becomes watertight. Again, touching on the different things that protrude through a roof. You get a lot of process piping, vents, antennas, beacons, chillers. All those things need to be protected. If you take note of the picture in the bottom right hand, they're using a copper conductor on the roof. So when they get to that metallic body, they will use a bimetallic fitting and do aluminum around that metallic body. One of the things in recent times too is buildings are getting very fancy, and the one thing that really teed off us lightning guys was everyone was doing glass rails now. So we had to come together as an industry and really start figuring out how to be creative. The one thing about lightning protection, and you guys will know this with your towers and antennas, if a metallic body that is 3/16 of an inch thick and continuous can take a strike. So it does not require an air terminal. So for example, on this glass handrail, this one was actually in Philadelphia, and originally did not have that top cap going across it. And the owners did not want to see the air terminals. There would have had to have been an air terminal every, a 4 or 5 foot air terminal every 20 feet sticking out in between the seams. So they got with the architects and engineers, and we constructed a 3/16 inch thick cap to all the way around. So all the bottom pedestals are bonded into the structural steel. So now that glass rail can take a strike on its own. Again, if you look at the picture of the copper creature there in the corner, thick enough to take a strike, we can just bond it in and not have to put an air terminal on it. So keeping the visual aesthetics of what we do is very important as well. See a lot of green roofs these days. Even in Omaha, they're coming quite a bit. We have to take special consideration for that because we can't put any aluminum, in the earth. So we got to keep everything copper and keep everything protected. Solar panels, another big one. It takes a lot of extra bonding, air terminals to protect them. So we talked about kind of the strike termination devices, air terminals. Now we're going to talk about conductors. Conductors are the lifeblood of our system. They're what take the strike from the strike termination device and direct it to ground. Obviously, conductors normally for lightning protection systems come in obviously copper and aluminum. And then we have class 1 conductors, which are structures under 65 feet, and class 2 conductors, which are a little bit thicker for taller structures above that threshold. So kind of one of the things about grounding that's very important in conductors is each air terminal has to have 2 paths to ground. So you'll always see multiple paths running across a roof to make sure that every air terminal that's tied, there may be 400 air terminals on a building and each one has to have 2 different paths to ground. Isolating the charge is not an option. We get a lot of people, they'll be building a steel building. They'll say, well, let's run down leads on the exterior of the building in the PVC. Because we're afraid that, the lightning's going to jump to the steel and it's going to fry everything that's touching the steel. Well, they don't understand the concept of lightning protection and grounding, and we have to bond that steel anyway because it's a side flash point. If we didn't bond the steel to the grounding system and it did side flash, that's where you would have some issues. So it's almost impossible to isolate the charge. You want everything to take the charge and without event because it's grounded properly. Some different pictures here of some different roof connections. If you look at the top one, we call that a through roof connection. So that would be a connection where it's a 1-inch PVC coming through the roof with a threaded rod. The bottom side is coming out there and connecting to the steel, and that's what you see on the top side. The other one that a lot of people don't understand, especially in wood structures, we can conceal everything in there. And they're like, well, man, that lightning is going to come down that cable and it's going to touch the wood and set it on fire. Again, they're not understanding the low impedance path to ground and grounding. So obviously with correct grounding, you're alleviating that and not going to have an issue. Just some different pictures of some exposed conductors outside. I talked about bonding the services. There's an example on residential where they're bonding the silicock of the water system so that everything's tied in. Some good examples of bonds and stuff on roofs, very common. Roof drains. You get a lot of roof drains on big commercial buildings anymore. Every one of them gets bonded, especially if it's within 6 foot of our primary conductor, again, to alleviate that side flash. Bonding of the services, gas, water, electrical, the 3 main on every building. One of the most important pieces, again, because we are trying to alleviate side flash. So that one's a very important piece to the puzzle for lightning protection. I mentioned this before. It's not really relevant in much commercial, but in residential and wood frame structures, CSST, there's been multiple lawsuits. There's been much lobbying from state to federal levels to try to get a better way to do this because it's just very vulnerable to lightning strikes and can cause a lot of damage. Again, here's one that got hit by lightning, created some perforated holes in it. Now you have a torch arc. You have major damage occur because of that. Grounding terminations. This is one you guys will pay close attention to because this is, in your guys' world, this is extremely important. Soil factor, major conditions. Around here, we're pretty fortunate. We do have some sandy ones, but pretty good. We started getting into Missouri, southern Missouri. It can be an extreme challenge because of the level of bedrock, clay, and stuff of that nature. A lot of people get hung up on ohms and resistance. Very important, however, ground resistivity is what it is. Obviously, the lowest resistance or lowest ohm level is the best, but if you're in a position in southern Texas where the ground resistivity is 25 ohms, you're going to have to take some extreme considerations to get it below that. Single point grounding, we talk about that. A lot of times we do a lot of data center work. This would make sense too in the project I helped Jim out with on one of his towers, where you guys have a big tower that's obviously going to take multiple strikes a year. So everything at that site, from the fences, the generators, the inside of the building, you have intricate grounding halos, and everything is bonded and grounded to a single point ground, which is extremely important in that field. Some different pictures of some different grounding terminations. Ground rods obviously are the normal standard. We use 3/4 by 10 kind of as our minimal, even though we only have to use a 5/8 by 8 if need be, but we like to carry one. A lot of our government and military installations require 3/4 by 10 anyway. So that's what we try to use. If you get into an area where a ground rod is not feasible, you can do multiple things, whether it be a ground ring. You'll see a picture there of a ground fan, which is normally a 24 by 24 inch copper plate you bury 3 feet below the earth if you can. All suitable grounding terminations.
Rusty?
Yes, sir.
I have a quick question. Some electricians are trying to tell me that CAD welding is not really looked upon as fondly as it used to be. Is it still a good bond when you're doing like a ring ground?
It is. So what we see a lot of CAD welding, mechanical's fine. CAD welding's good. We're seeing a lot of irreversible crimp now for the connections. CAD welds are the normal for still military and everything else, and they're very good. Done correctly, they're a very, very good termination. You're seeing now with technology, irreversible Burndy crimps has become the new normal for a lot of that. The problem with, Burndy crimps is they're expensive. The tool's expensive, they're expensive, where, you can use a CAD weld mold 50 times, and then all you're paying for is the shots. One of the concerns in what we've seen is CAD weld is not done correctly. So if a CAD weld is not done correctly, you have some impediments in your mold. It may look good, may pass muster, but 5 years go down the road, someone kicks it with their foot and it crumbles off. So CAD welds done correctly have always kind of been the gold standard. But in the electrical world, they don't CAD weld as much as they used to. So that's why you see them especially going to Burndy crimps now. The next very important piece of lightning protection is obviously the surge. Lightning protection, first and foremost, is trying to protect the structure from any structural damage, but of course, inherently, it's going to protect it from any side flash or damage to electrical devices. That is helped by the surge protection side. When I say surge protection, I'm not only talking about on the electrical service, but on everything. Low voltage controls, CATV, networking, very important, because what happens is you may have a very nice protected structure, and the old wives' tale of lightning is going to hit the highest point is absolutely not the case. And so you could have a 50-foot tall building that is thoroughly protected with lightning protection, and lightning is going to strike right next to it and find a Cat 5 cable going through the ground, and come in and cause massive damage to the communication infrastructure. So that incoming surge on the incoming services is extremely, extremely important. Obviously, you also have, your old plug-in devices. They're a great second line of defense for any side flash. Even with technology and surge on all the incoming services, lightning protection, there's so much cabling in today's modern structures that you can't put, say you have 10,000 Cat 5s running through a commercial building, and yes, each port that they lay down on is grounded and everything else, you're going to catch the old abandoned Cat 5 that was cut off and thrown in the attic, and stuff can still side flash sometimes. So just second levels of protection are nice, and that's why a lot of people still use the surge device on the end of the device. Our industry does a lot of research. So the Lightning Protection Institute has been around since the 50s in conjunction with the ULPA, the United Lightning Protection Association. And we're such I'd say a niche industry where we all get together and finance a lot of research through partners of ours. So they'll do things, this is one that was University in Florida. They actually have a test facility so they can generate lightning and test the different outcomes of different systems, different failures, things of that nature. So this is a triggered lightning experiment. So we can actually test different devices, different things in the technology. The thing about conventional lightning protection, or people call it Franklin lightning protection, is it really is not a whole lot different than when good old Ben Franklin discovered it and figured it out over 200 years ago. But we have come a long way, and the code cycle and standards redo every 3 years. There hasn't been any monumental changes, but we find, especially in the electric sensitive and in the flammables, a lot of new ways to protect things with some extra bonding and some extra things to make sure that the system is going to work every time. So there's a lot of reporting on lightning protection, and a lot of boards that the lightning industry gets involved with to help educate and make sure that everyone is aware of lightning protection. The thing about lightning protection is, out of all the forces of Mother Nature, lightning is the only one that there is a reliable solution to protect from. There's nothing you can do to stop wind or anything else, but you can protect yourselves from lightning. A lot of our work we do is specified. So let's say we get a new data center coming to town. For example, everyone knows where Facebook's being built. They go through and they have architects and engineers that normally don't know a whole lot about lightning protection. So they reach out to us and help them do a design build spec, so we can explain to them and help them design the system that's going to be adequate for their structures. So again, we referenced before the NFPA standard, UL, and the LPI standard. The other thing that's very important with lightning protection is a third-party certification. On normal structures, we as a company, certify every structure we do lightning protection on. Not only from a credibility standpoint, so it's just not us telling you that your system is done to the standard. It's the third party that comes in. They require as-built photo documentation. They have engineers review all of that and actually have an inspector come out and review the system. There's 2 third-party certification services. The LPIIP, which is the Lightning Protection Institute Installation Program, which is Intertech is the background of that. And then UL Master Label Certificate, which has been around forever, except now UL is for profit, so no one really likes to work with them anymore, and their inspectors look at fire trucks most of the day and then come try to look at a lightning system. So normally we're telling them what's wrong with it. So those are the 2 different third-party inspection services. The Lightning Protection Institute Inspection Program has the Master Installation Certificate, which is based on a complete system, whether it's new construction or redo of an old building. They also have the Reconditioned Master Installation Certificate. So if a project was previously certified and it has a license number, and some work has been done or it's been brought up to the latest code, it can get a reconditioned master. And we also have the limited scope inspection reports. For example, if a air unit is added to a building 2 years after the building was built, the original master installation certificate becomes null and void because they added something to the lighting system. So now you can do a limited scope. They'll just take a look at that air unit, make sure it's tied in correctly and everything's good. That limited scope then offsets the installation, the master installation certificate, and your certification is still good. UL does the same thing. They have the master label. The letter of findings is the same thing as the limited scope. Where UL does have the major authority over lightning protection is on the manufacturing and part side. So UL 96A is the guide for installations. UL 96 is the ANSI standard for lightning protection components. So for example, if I decided today that I was going to start manufacturing lightning protection components, every nut and bolt would have to be applied for, inspected, and certified by UL to be a UL listed and labeled lightning protection device. Quality assurance, lightning protection, couple different things that you see in our industry. Electricians normally don't do lightning protection, and they're not certified to do so. Every once in a while they try, but they're not trained to do it properly. It's not in any of their electrical apprenticeship training. Lightning protection is an absolute separate subset of certifications and training. So all of our contractors that are reputable in the industry, the company is always UL certified, and then all the installation professionals should be LPI certified. So over time, it's like an apprenticeship program. There's different exams that are proctored and taken where you can get your certifications. It starts with an LPI certified journeyman installer, and then you get to a LPI certified master installer, and then you can get to a LPI certified master installer designer. So that's kind of the important part of the contractors and the installers that are doing the systems. Obviously, the materials and methods should comply with all the standards, very important. The other thing is certifications and industry affiliations, which is extremely interesting in our industry because all of us lightning protection professionals, for the most part, get along very well. So we get along with our competition. We do favors for each other. We give each other work in certain areas. We all get together once a year for a big conference, kind of like you guys are doing today, to discuss the trends, and we help each other out as an industry, which is very nice. For example, my brother-in-law, Tyler, who's the president of our company, is on the board of directors for the LPI. He's on the board of directors for the ULPA. We're both LSA certified instructors. So we try to be involved in the industry to help the industry grow and help stay on the cutting edge of anything new that's going to come out. My favorite part is you see a lot of non-standard devices. About every 5 years, they rear their heads. The biggest one that you see is the single mast ESE type system. So these are these beautiful spaceship looking things they put on a pole on top of a roof, and they use all this formulated math where there's no delta because no one can actually figure out the math, and saying that it's going to protect a sphere of 300 meters around this building. About every 5 years, they apply for compliance with NFPA and UL and get rejected every time. They don't follow science. We actually have lawsuits against most of the manufacturers where the courts have actually issued injunctions not allowing them to market them as a lightning protection device. And there's numerous documented failures. One of the most recent was at a, not Disney World, but another famous open air theme park in Florida, where these were located everywhere, and lightning still struck a ride and killed 3 people. And there was one of these air terminals on a mast, literally 50 feet away from this, and it's supposed to have a 300-meter range of protection. These are some more of the different heads of the different ESE manufacturers. Again, not recognizing the United States, They exaggerate their protection ranges. They have all been ruled false by science. The other thing is 2 out of the 3 main ESE manufacturers issue a $10 million insurance guarantee. And it's about a 40-page document. Not one has ever been paid out, and they're just absolute BS, for lack of a better term. These are some examples, pictures, failures of the single mast system. As you can see, there's one on the other ridge of the roof. Again, supposed to have this exaggerated 100 to 300 meter, depending on the style. And obviously the house right next to it got hit and took a direct strike. Another one here, lightning hit the building, caused structural damage. It has a ESE air terminal on it. Dissipation systems, they don't work. They've been rejected by pretty much everyone in the industry. The science behind it is that the fuzzy ball is going to dissipate the static electricity and lightning's not going to strike. However, what you have happen is lightning strikes these things frequently, and they are grounded, which is good. So they're no different than an air terminal, except they're supposed to not allow the lightning to hit. They're supposed to dissipate. Well, all those little metallic fuzzies on the top, when these get hit, become hot embers now falling all over and putting holes in TPO roofs. So they've tried to validate them for many years and they keep failing. You see a lot of dissipation systems on substations. Why you see them on substations is they're not trying to say lightning's not going to hit. When they're on substations and around the substations, they're helping dissipate some of that electricity from the substations. Again, here's some of the field testing at one of the places in New Mexico that does a substantial amount of testing and really putting these different systems through the grind to find out their scientific knowledge and figure out if they're going to go, and they fail every time. Not one has passed muster. Here's some different photos of just some different lightning protection things. As I kind of mentioned earlier, you know, if you're ever driving down Dodge Street and you start looking up, now you'll maybe notice the little air terminals sticking up everywhere where you probably didn't before. Again, they're pretty visually appealing now to where you don't see, like you used to, the big tall air terminals and stuff of that nature. Rooftop decks, another one you see a lot of. You can see it's got air terminals, everything's concealed, no conductor except for the outside. So you're providing a level of safety for that area in the pool, and it's still not, you know, affecting the visual integrity of the property. Some of the trends in our industry, you'll LEED certified buildings, kind of dying down a bit, but that was the biggest thing going on for the last 5 years. The insurance industry is finally embracing us to an extent because they're tired of paying out all these claims. So they're doing renewals and discounts. State of Florida is the only state in the United States of America that actually has building requirements. And so for certain occupancies, schools, hospitals, it has to have a lightning protection system, or otherwise you cannot get a CO. Agencies customizing lightning protection standards. The one I mentioned earlier, SLS, Scientific Lightning Solutions, they are huge in coming up with a way to protect non-conventional things such as launch pads, space shuttles, because you have to come up with something a little bit more intricate than our codes and standards currently have. We talked about CSST gas piping. That's been a big one in our industry for a while because of the problems it's caused. Then you're starting to see a lot of where does the liability fall with lightning protection? It's Mother Nature, and most people's contracts, acts of God are excluded, but you're seeing litigation now of lightning protection system failures. That's one of the reasons why we certify everything through a third party when it's a new lightning protection system. We've been, since 1978, we've been incorporated and haven't had a failure yet. I'll knock on my wood desk. But it's just very important that the lightning protection is done correctly. For an example, I get a lot of people that say, well, I just want to do these high points and don't want to do everything else. I don't want to run all these conductors everywhere. And I say, here's the deal. I'd rather you not have a lightning protection system than have one that is half done, because now you're giving a lightning a path to travel, and the correct bonding and stuff is not done. You're going to potentially cause more harm. So a lightning protection system is very important to be complete, thorough, and meet the standards. Some of the things we do a lot of outreach. Leon the Lightning Lion, we do this with grade schools. Lightning Safety Awareness Week, which is usually about the second to last week in June. That's when I travel around and do a lot of presentations to schools, just educating kids on lightning. You know, thunder roars, go indoors. That's our slogan. Just different things to keep people safe when they're outside when lightning's going to come. Kind of final thing, you know, I kind of touched on this before, but it's most common force in nature. Buildings are threatened by on a regular basis, and there is reliable protection against it. Places of responsibility to provide this protection for everyone involved. We spend a lot of great deal doing these presentations for the specifiers, architects, and engineers, helping lightning protection get spec'd into a lot of other facilities that are in need of it. And that's it. Thank you for your time. I really appreciate it. Please feel free to ask any questions.
I've got a question, Rusty. I have here a lightning dissipator that came off of a tower.
Yep.
And most of us that have had to purchase towers, this is usually probably an option, if not a standard feature of the tower. They put them at the tops of the towers,
yep,
on the sides of the towers. And of course, you answered a lot of the question about dissipators, but if they're not that effective, why in the world do they sell them? Other than to make a buck, of course. I mean,
yeah, and that's,
is there any science? Is there any science behind it? I mean, I could see where this one's been struck, because like the ends of the points here are dulled off with a ball
yep.
of hot metal. I mean, you can see where it's obviously been hit. But
you know, like the one you're showing me there is a better constructed version. And like I said, for some of those specialty applications with substations, towers, there is some dissipation that does happen with those. However, the marketing behind them, especially there's one called Lightning Eliminators, and that's the little spline ball one you saw there. Mm-hmm. They guarantee it's not going to strike it. And they strike all the time. Again, it's Mother Nature, it's lightning. Yes, you can help dissipate some of that static, which again, substations use the ones like you just showed there, Mark. And there is some success to the dissipation, but it's not going to alleviate the lightning strike completely at all.
Well, you know, I've always been on the mindset that lightning is so unpredictable anyway, and if it's going to strike somewhere, it's going to strike. So
absolutely, absolutely. And that's what I tell people. There is no rhyme or reason. Lightning does strike twice. It'll strike the same spot twice. Lightning, again, one of the best examples I give, because everyone seems to believe that lightning is going to hit the tallest point. There was a project where there was a house that sat about 100 yards down a hill from two large structures up above, and that house took a direct strike and burned down. And it made no sense to the theory that lightning would strike the highest point. But like you said, lightning is so unpredictable and becoming more forceful through the years. You know, the density map changes substantially with the amount of strikes and the intensity of them creeping up into the middle United States more than ever. If you look at that map back in the, I don't remember when it started, late 90s at some point, you know, the orange was really focused, you know, down in the Gulf region. And it's just with weather patterns and everything else, and with structures and with everything there is, it's just changing substantially.
Well, and when I lived out in central Nebraska, we did take a lightning strike that did considerable damage to electronics in our home. But here I had a 65-foot tower at the end of my house.
Yeah.
And it never even touched the tower. It came in through the power line off the power pole out in the alley.
Yep, absolutely. And that goes to my part where I say the equal potential bonding and the SPDs and all the incomings are so important.
Right.
I got to drop in here and comment about KFAB. back about 1975, back when I was working for them. They've got 4 towers out there. First 3 are for the directional array, and there's been times back when you drive out there. Back when we had transmitter shifts, you'd be driving down 370, and you'd watch the lightning strikes come down and hit the tower, and it might travel across. It might hit one tower and then go over to the next one, and then over to the next one. Just went over there, and in the process, on occasions, it would destroy stuff. Matter of fact, the phaser cabinet, we took a hit one night, and it vaporized all the coils inside the phaser.
Wow.
What we ended up doing to solve that problem was we worked with LEA, and they put these top hats on the first 2 towers and the very last one, which was the FM. And what it consisted of was a device that looked like it was like a pyramid, and it gradually went up, and it had barbed wire starting at the bottom of the pyramid and worked its way all the way to the way of the top of the pyramid. We put those top hats on the towers, and that solved a lot of problems. And what happened, I'd be out there. I remember being out there for whatever reason. We were doing something, and a storm came through, and it was dusk. And I went out there, and I could hear this kind of sound.
Oh, yeah.
And I looked up, and I saw a blue halo coming down from the cloud to those top hats, one of the top hats. And it was dissipating that cloud. And I want to tell you, these things really worked. They did the job. And the other problem we used to have was we'd have trouble with high winds going across the guy wires, and there'd be so much force of wind going across that would produce static electricity, and the static electricity would discharge across the Johnny balls. And you'd hear this pop, 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 pop,
Yep.
pop, 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 and you'd look, and of course it knocked the transmitter off the air because it's taking the RF to ground. We got around that by putting 10 megohm resistors across each Johnny ball, and that solved that problem.
Yeah, no, and that's, when you start talking about, especially what you guys do with your towers being so far up there, and just the static electricity alone, the amount of grounding and conceptual things that have probably been done over the years to help alleviate that, it's intriguing, because you guys have a little bit more to lose. And that's why, as Jim, with what we helped you out with, the grounding is so important on that.
Oh, absolutely. And I got to tell you guys, Rusty and his crew did a phenomenal job on the grounding out there at the Springfield Tower site. For those of you that don't know, back, I think it was April 25th or so, we got vandalized out there, and the copper thieves showed up, and they cut off all the grounding around the tower, around the building, on the generators, electrical grounds. They even took the grounding busts that we had. They took them and took them off the building, and then they broke inside the building and did a real major number on 1019. But anyway, Rusty and his crew came out and did a phenomenal job. And I want to tell you, if you've got any kind of problems with grounding, these are the fellas to talk to. They know their stuff.
Yeah, and we do a lot of, thanks, Jim, I appreciate that. We also do a lot of, we have not a separate division, but we have some people in the expertise where we do a lot of ground testing and stuff for problem areas. We do a lot of military ground testing, stuff of that nature to really identify. Because the other thing that you see and people don't realize, even around here, so grounding can not be as effective as years go on. For example, you take towers that take a lot of strikes, and if you're in a sandy area, you can dig up those ground rods and there'll be a lot of glass around them. is the best way to put it. So where that grounding isn't getting the resistance to earth or touching the earth as much because of that. So people don't take that into consideration. So we do a lot of different testing and stuff to identify, issues with grounding systems that have been in place for quite some time.
First, I was going to ask, do you guys do like a grounding audit for a station where you can go in and evaluate what's there and make recommendations on to make it better, or how effective it may be, or what needs improvement?
And we do very, very similar to that. We're not the experts in your field per se, but we can go in and tell you what needs to be grounded, what's wrong with what's there, stuff like that. And we do all that type of stuff free of charge. We'll come out and make an assessment, and we do an inspection. And then if we identify some areas, or if you tell me you're having problems, then we can even bring in, our grounding equipment, do some 3-point tests, stuff like that, to see how adequate the existing grounding is, and go from there.
And our studio, starting in 2014, took 6 major hits in 4 years and did well over $100,000 damage.
Wow.
And what it was is a 65-year-old facility that, while they thought they were going to do a floating ground on the building because the tower was well grounded, but the building, if the building isn't grounded, lightning will never see it. It'll just go outside. And
Right.
That failed miserably, obviously.
Yeah, right.
We've since put in bus bars, and
Yep.
one of the famous ones, I recently asked an engineer, well, how's the grounding at that tower site? Well, I don't know, whatever was there in 1980 when we moved in.
Right.
Which turns out to be nothing. And now they've been digging ground rods and cables and bus bars and all that, putting it in.
No, and to your point, it's, grounding and lightning protection is a afterthought. So they put it in, and then they think, well, we have it, and it lasts forever. And, a good system can last a very long time. But like I stated before, a lot of times connections get kinked, people, mowers hit stuff. I mean, it's got to be maintained and visually inspected. And like old grounding needs to be tested again to make sure that you're, still getting the resistivity that you want.
Is there any merit to those grounding meters where you test the ohm resistance and amperage on the ground to see how good of a ground it is?
Absolutely. Yep.
I've seen a site where, in fact, we may have this problem at the 660 site. I think we've got a grounding issue out there. That site was put in 1968, somewhere in that area. And what I've seen happen in the past is the ground rods going around the building, off the tower or whatever. You get these lightning strikes and it goes to ground like it's supposed to. But over a period of time, you get enough of these strikes, and what happens is around the ground rod that goes into the ground, the soil becomes a piece of glass.
Yep.
And you lose your ground conductivity. And I think I've got that problem going on right now at our 660 site.
It happens a lot, Jim, and it's a simple fix, because, I tell people this, all you have to do is go 5 feet, 6 feet away from that, put new ground rods in, and then connect to the tails above ground, and then that should alleviate it, but people, they don't realize that, you can go, especially down in really sandy areas, they have some at our conference we go to, they'll bring in these, 11-foot long, basically chunks of glass that were around ground rods that have been in the ground for 30 plus years.
Yeah, exactly.
It's fascinating.